So here we go with 6.5b notes. This is the last set of notes, I believe, for Mod 6. Yes, it is. You have a quiz coming. It is scheduled for Friday. You'll have to verify with the sub whether that is going to take place Friday, or there's a chance it could be pushed to Monday. I don't usually like giving tests or quizzes on Mondays, but I'm going to do whatever the other teachers are doing. Let's see, synthetic division. This is a shortcut to what we did yesterday. The long division that we went through is a little bit more complicated. Synthetic division is fairly simple. However, synthetic division cannot be used for every division problem. Long division can be used for every single problem. So you need to know long division because there will be times when you come across something that synthetic division cannot be used for. Now, synthetic division is used best when this one out here, your divisor, is x plus a number or x minus a number. It doesn't work if you have x squared. It doesn't work if you have x cubed. It has to be x plus something or x minus something in order for you to use synthetic division. And I believe at the bottom of the page, it says that right here. We usually use synthetic division only for factors that are in the form x minus h. And that technically means x plus h as well. We'll talk about that in a minute. Okay, so going back to the first problem, this is actually a problem we solved in yesterday's notes. Yesterday we went through the whole long division process and we did this whole thing. So at this point you need to be able to do that on your own. Now I'm going to show you how to get that same answer using a process called synthetic division. Okay, now once people learn synthetic division, they love it. And I like it too. It's my preferred method. But like I said, there's sometimes you can't use it. So here's how we use synthetic division. The first thing I do is I look at this x plus 2. If I were to set x plus 2 equal to 0 and solve for x, I would subtract 2 from both sides. And that would give me x equals negative 2, correct? Well, that negative 2 I'm going to call my box number. And I put a little box around it like that. Okay? And then I'm going to list a series of numbers here. And let's see. I'm going to erase this if that's okay, so I have some room here. I'm a little particular, can you tell? Okay. So I'm going to list some numbers here. I'm going to put a 1, a 7 with a little bit of space between them, a 3, and a 4. Now my question to you is, where did I get those numbers from? Well, let me tell you where I got them from. 1, 7, oops, let's not erase it, 7, 3, and 4. They're my coefficients from the problem. If I had a spot that was missing, like yesterday when we had to plug in like a 0x squared, I would have a 0 somewhere in there, wherever that placeholder was. So you do still have to have a placeholder. Now I'm going to skip a line, and this is the part where we do our synthetic division. It kind of is the same process as long division, it just takes out all the x's. So the first thing I'm going to do is bring down the first term. Okay? Now, I'm going to take this 1, and I'm going to multiply it by my box number. What was my box number? Negative 2. What is 1 times negative 2? Negative 2. My answer goes right there. Now I just add 7 plus negative 2. I'm going to add down. 7 plus negative 2 is 5. It's the end of my first cycle. Take this number, the 5, multiply it by the box number. 5 times negative 2 is negative 10. And again, I add going down. 3 plus negative 10 is negative 7. By the box number again, negative 7 times negative 2 is positive 14. Add going down, 4 plus 14 is 18. The division part is now done. Okay, now when you use synthetic division, this last number here is always your remainder. Okay, so I have a remainder of 18. Didn't I have a remainder of 18 in the original problem? And then these numbers in front, the 1, the 5, and the 7 that I got, guess what? 1, 5, 7. I'm sorry, negative 7. That's actually important to note. And I have a negative 7 over here. They are the coefficients of my answer. Now, I have to keep in mind that if I started off with something that was x to the third, and I divided by something that was x to the first, x to the third divided by x to the first, I am no longer having a third degree equation. I have a second degree equation. So yes, these are coefficients, but it's 1x squared plus 5x minus 7. So we're counting down the exponents, x squared, x, and then nothing. And then plus my remainder. Let me write that a little nicer. My remainder over what I was originally dividing by, which was x plus 2. That is my entire process. We like that because it's easier. However, we can't always use it. Let's try another one. Okay, h to the third minus 27 divided by h minus 3. I think we did this one yesterday also. So here's where I'm going to get my box number from. So if I set h minus 3 equal to 0, I would add 3, and you don't need to show your work for this part if you know that your answer is just going to be 3. It's actually always just going to be the opposite of whatever that is. If that's a negative 3, 3 is your box number. If that's a positive 3, negative 3 would be your box number. Okay, so my box number is positive 3. Now I have to be careful as I'm listing my coefficients now. My first coefficient is 1 because that's the coefficient for h to the third. I am missing h to the second and h to the first, and then I have negative 27. So this is my h to the third column, my h to the second, my h to the first, and then my constant finally. If you do not put those zeros in, you will screw up your answer royally. Okay? So, what do? Bring down the first number, and then take that and multiply it by the box number. 1 times 3 is 3. That's where I write my answer, and I add going down. 0 plus 3 is 3. Next step, multiply by the box number. 3 times 3 is 9. Add going down. 0 plus 9 is 9. Now I take that 9, multiply it by the box number. 9 times 3 is 27. Add going down. Negative 27 plus 27 is 0. Remember that last digit is always your remainder. If my remainder is 0, then guess what? We have something that is a factor. So, again, I had an h to the third, and I divided by an h to the first. So if I take the h to the first out of that, in other words, h to the third over h to the first, I'm left with an h squared equation. So this new equation, the new expression is always 1 degree less than this because we're taking out one of those degrees. So I have 1h squared, positive 3h, positive 9, and no remainder. And that's my synthetic division for that guy. Oops, sorry about that. Oh, come on. There we go. Sorry, I was trying to pinch it to zoom in. Okay. All right, let's look at the next problem. If one factor, I need to erase this a little bit so I can see what I'm doing there. Okay, if one factor of 4c to the third plus 20c squared minus 9c minus 45 is c plus 5, divide to find another factor. What does it mean to be a factor? Well, we just found one, didn't we, in the last problem? If this is a factor, they're saying that when you divide this by this, you get a remainder of 0. Okay? So, what I'm going to do is I'm going to take this and divide it by this, and what's left over will be another factor. Okay? So, if c plus 5 is a factor, what is my box number? My box number would be negative 5. Hopefully you're getting the hang of that now. And my coefficients, let's see, c to the third, c squared, c, and then my constant. I don't have any missing terms to worry about. So I'm going to put the 4, the 20, the negative 9, and negative 45. And let's do our synthetic division. Bring down your 4, multiplied by the box number. Negative 5 times 4 is negative 20. And I'm going to add going down. That gives me 0. Multiply by the box number. Negative 5 times 0 is 0. Add going down. I have negative 9. Negative 5 times negative 9 is positive 45. Add going down, and I get 0. What's my remainder? 0. Should my remainder be 0? Yes, because they said that was a factor. If I did not get a remainder of 0, that means that I did something wrong, because they already told me that was a factor, which means it has to get a remainder of 0. All right? So I had c to the third, so now I have 4c squared. I don't need to write plus 0c. I just need to write the minus 9. So guess what? There is another factor of that particular polynomial. So here is one factor, and here is another factor. So I just used division to help me find that second factor. Okay? All right, let's move on to the bottom part of the notes. So, synthetic substitution is actually very simple. The opposite of synthetic substitution, or an alternate, would be something called direct substitution. And so, for example, in this first problem right here, where it says f of x equals 2x to the fourth minus 15x cubed plus 4x squared plus 21x, if I wanted to solve that for x equals 7, what I could do for direct substitution would be just plugging in the 7. We talked about this a little bit on yesterday's notes. 7 cubed plus 4 times blah, 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 blah. I'm not going to write the rest of it because that's actually really, really extra, for lack of a better word. There's a lot of places where you could potentially make a mistake, and we can use something we can use basically the same thing as our synthetic division to get us to the answer a little bit faster. So when we use synthetic substitution, they're giving me the box number. They have already set it equal to 0, and they're telling me that x equals 7. So 7 is my box number. Now I just need to list all of my exponents. I'm sorry, my coefficients. So I'm going to put a 2, let's see, fourth, third, second, and then plain old x. So the only missing term I have is a constant. If it's at the end, I don't need to worry about it. Okay. So, 2, negative 15, positive 4, and positive 21. Let's do plain old synthetic division on this. Bring down the 2. 7 times 2 is 14. Add down, I get negative 1. Multiply by the box number, negative 7. Add down, negative 3. Multiply by the box number, and add down. Now, when I am looking for x equals 7, my answer is not 2x to the third minus 1x to the second. I don't do that like I did with the synthetic division. When they're giving me a value to plug in, my answer is only this last value, or the remainder. So, the way I would write my answer, if they're telling me to find x equals 7, in other words, they're telling me to find f of 7. Well, f of 7, or in other words, the remainder when I divided by 7, is 0. That's what my answer would be. Pretty simple, yeah? All right, let's use synthetic substitution over here. What's my box number? Negative 2. What are my numbers across? Let's look carefully. 4, 2, 20? No. X to the third, x to the second. There's a missing x to the first term, so there has to be a 0 right there. And then the 20. Again, will royally screw you up if you miss that placeholder there. So let's do our substitution, or our division. Bring down the 4, multiply by the box number. That gets me negative 8. 2 and negative 8 is negative 6. Multiply by the box number. There's my 12. 0 plus 12 is 12. Multiplied by the box number, I get negative 24. Adding down one more time, I get negative 4. So, if this was a synthetic division, my answer would be 4x squared minus 6x plus 12 with a remainder of negative 4. But they are asking me, let's see, they're using g of x this time, so I can't write I can't write f of negative 2, I have to write g of negative 2. And that is equal to negative 4, because again, they're only asking for the remainder in that case. So the answer is negative 4. Like I said before, we only use synthetic division if you've got to form x minus h. So for example, good ones would be something like x minus 5 or x plus 1/2. We can do a fraction there. We can do a decimal there. We can do pretty much anything there as long as the x is by itself. Bad ones we cannot use synthetic division on. Something when you have an x squared or an x to the third or x to the fourth, or even something like this. We cannot do synthetic division when there's a number in front of the x or a coefficient in front of the x. So, when can you use synthetic division? In cases like that. We cannot use it in cases like those. Okay? All right, happy studying.